this is Mrs. Lemke, and I'm here to just add a little clarification to your understanding of the empirical rule. I looked at the results from last class's exit slips, and it just seems like we need a little bit of clarification. So you know that the empirical rule has three numbers involved with it. 68% pertains to this piece of the graph that I'm indicating here with this red arrow. So from one standard deviation below the mean to one standard deviation above the mean captures 68% of the population. I have a little note to the side here. It says, in addition to the given pieces, like 68% for example, the empirical rule basically lets you find halves and it lets you find tails. So for instance, if I think about what is half of 68%, because this line is a line of symmetry, I know that each of these pieces is 34% of the population. I also know, because of the 68%, since 100 minus 68 leaves me with 32%, that means that each of these tails, right, the parts that I do not have a label on yet, each of these tails is 16%, because half of 32 would be 16. So this tail is 16%, and I am not pointing there just to this one section. I am including everything up to as high as we go, right? And that's even past the third standard deviation line. This graph comes down and it hugs the x-axis, and it just keeps going. So this entire space on each side is 16%. So that's what I mean when I say that each number lets you find halves and it lets you find tails. We also need to bear in mind that the entire graph is 100%, and I'll explain that in just a little bit. Explain the error that some folks made. Okay, the next such number in the empirical rule is 95%. I know that in addition to knowing 95%, I also can know halves and tails based off of this. So 95% cut in half is 47.2. So I know that this line is going to give me two chunks. From this blue line to this blue line is 47.5% of the population. From this blue line to the center, or the mean, is also 47.5. And then if you think about 100, because that's the entire graph, minus 95, that leaves me with 5%. And that 5% has to be split between the two tails that exist. So there's a little itty bitty tail here, and there's a little itty bitty tail on the other side. And this tail goes past the third standard deviation line possibly, right? There could be data that's very extreme in value, okay? So this blue tail is 2.5% of the population, and this blue tail is 2.5% of the population. So the number allows me to know halves, and it allows me to know the tails. I know that the 5% that I had left over is split even Steven, because this graph is symmetric, right? You can split 5 a lot of different ways. Any older sibling knows that. If you're given $5 from your grandparents, you could give your younger brother 1 and yourself 4, but that is not how this curve works. This curve is symmetric. Okay. The next graph shows the last number in the empirical rule. And this one, I think, is the one that caused some problems in your answers in the exit slip. So this shows that from this line, which is 3 standard deviations below the mean, to this line, that's almost everybody, but it's not quite everybody. Do you see how there's like a little tiny bit down here? Little tiny bit of blue up here, right? So if we take 100 minus 99.7%, we're left with 0.3%. And then if you split that, because of symmetry, there's just a little dab down here and a little dab up here, 0.15%. So it's very unlikely to be outside of 3 standard deviations away from the mean, but it is possible. If I were looking at NBA players, right, there are a lot of NBA players that, if this were a graph of height, are out here. There are a lot of them because it's unusual, like they're unusual people in the first place. Okay, So I've got 99.7% in the middle. And so I want to take 99.7 and cut that in half. And so cutting that in half will leave me with 49.85%. So that's going to be what this chunk is from here to here, and that's what this chunk is from here to here. Would be 49. Oh my gosh, my writing. I didn't even realize. Sorry about that, guys. I'm curled up on the couch, and that is probably not the best way to record a video because my computer just slipped on my lap. Should be using a table. Sorry about that. Okay, so 49.85. Now, you still can find pieces other than these if you sort of combine what you just figured out. So for instance, if I want to know from 2 standard deviations below to 1 standard deviation above, I can use these pieces that we figured out earlier to do that. So for instance, this guy is 2 below. So let's go to this picture, okay? And I know that the piece right in here, that was 47.5. And that is true on every bell curve, on every normal distribution, that this piece would be 47.5. Now I need to know from the mean to 1 standard deviation above. So I go back here, I say, oh, I already figured that out. That's half of 68, so that's 34. So if I wanted to know those 2 pieces, I could just add up 47.5 and 34. I'd say, oh, that's 81.5% from here to here. See how clever that is? So I hope that this helped, and we're going to learn more with the normal distribution in our next lesson. And hang in there, guys. Almost to the end. You're doing a great job.